Good afternoon, all of you. Is my voice clear? All of you there are not. Sukanya,
Yes, sir.
వింటున్నారా అందరూ?
Yes, sir.
రెస్పాండ్ కండి. Right. So I will start the class. So we have completed the derivation for expression for the efficiency of the amplifier, power amplifier. Which amplifier? We have transformer coupled class A power amplifier we have seen. Okay, now we have to go for a circuit of class B push pull power amplifier. Okay, so we have class A, class B, class AB, class C, and class G amplifier power amplifiers are there, in which we have completed class A power amplifier. So now we have to discuss about the class B push pull power amplifier. Okay, in the class B amplifier there are two types: push pull power amplifier and complementary symmetry push pull power amplifier. Okay, so first one is we have a class B push pull power amplifier. So in the push pull power amplifier, it is used in the at the output stages of all electronic circuits. Okay, whenever high output power is required and high efficiency is required, this class B push pull power amplifier is mostly used. So how many transistors are present in the push pull power amplifier? Means two transistors, Q1 and Q2. So in the and on the transformer we have used is a center tapped transformers. Two center tapped transformers. Okay, and the load is a loudspeaker. So in the input side, this is called input transformer. This is output transformer. Okay. So you can have the two center tap transformers T1 and T2, and the transformer T1 is input transformer and also called as a phase splitter. It is also called input transformer. Is you can also call as a phase splitter, and it is required to produce two signal voltages which are 180 degrees out of phase with each other. So the input transformer or phase splitter will generate two signals which are 180 degrees out of phase. That means they are opposite to each other. So the signals which are generated through this transformer, T1 transformer or input transformer or phase splitter, as the two signals it will be generates V1 and V2, they are opposite to each other. That is 180 degrees phase shift. And the transformer T2 is output transformer and is required to couple the AC output signal from the collector to the load. Okay. So what is the load here? Load speaker. So the output transformer is used to couple the collector voltage. Collector voltage, it will be coupled to the load. Okay. It is coupling purpose. That is the reason it is a coupled. So output transformer or coupled transformer, coupling transformer. Okay. So and we have a how many cases we have to working principle is two cases. So for a working principle we have two cases you have to consider. So first case is where there is no signal. So what is the happen to the there is no signals means they both are cut off. The signal means there is no signal means input is zero means the transistor will cut off. So what will output? Output also zero. So there is no power output at the output side, and there is no power wastage in the standby. So and the power dissipation is zero. So power waste the output is zero, the power dissipation also zero. The power wasted in the transistors also zero. So when the signal is applied, so in the second case, what will happen? During positive half cycle of the input the signal, the base of the transistor Q1 is positive and the Q2 is negative. So the base of the transistor Q1 is positive and the base of the transistor to Q2. This is Q2, not Q1. Change this. Okay, this is Q2. So Q1 is on, Q2 is off. So what will happen? As a result, Q1 will conduct and while the transistor Q2 is off. When the input signal goes to the negative, so Q1 is turns off and Q2 will conducts. Okay, so is it clear or not? So whenever the positive off cycle is given, then what will happen? It is on, this is off. Then negative going cycle, it will on, this is off. Okay, so like this. So what will happen? Thus at any instant only one transistor in the circuit is contact. In other words, each transistor handles one off of the input signal. So then the output transformer joins these two offs and produces a full sine wave. Is it clear? So in the first, the signal whatever you are given in the signal, it is producing a two signals. So V1 and V2, and they are opposite to each other. The V1 is given to the Q1 and V2 is given to the Q2. So V1 is whenever it is positive off cycle, it is turned on, and the V2 is opposite to the V1. So what will happen? V2 is negative off cycle, so it will off. So and whenever it is negative off cycle, it is off and it will be on. The Q2 will on. So and it is given at the collectors of the each transistors IC1 and IC2, and both are opposite to each other and it is coupled. It is given to the output transformer. So and output transformer used as a coupling transformer, which couples the output voltage or output current to the output to the load or load speaker. So what will happen? At a time it will conduct only one transistor. So if you and the output transformer will couple up these two outputs. So what will happen? IC1 plus IC2 will a full cycle. You will get the output side. Is it clear? So off cycle will generated by Q1, off cycle will be generated by Q2. So the due to a coupled transformer, overall circuit will be coupled. 31st వరకు కాదు. అయిపోయిందా? ఇది అయిపోయింది. ఓకే. ఓకే. Okay, is it clear? So overall, the coupling transformer it will given to the overall output voltage or output current is a combination of IC1 and IC2. So this is the working of the your class B push pull power amplifier. So you can joining outputs of two transistors is never perfect and hence the output is distorted. Is it clear? So due to for example the Q1 is on, so but perfectly it will not on at a time. So as well as the Q2 is also off, it is also perfectly not off. So some conductivity is present in the Q1 and also some conductivity is also there in the Q2. So that what will happen, overall output is not the not perfect. So what will happen, it is having a some distortion. So due to the class B power amplifier having a two transistors are there and they are not perfect, due to this the output is also not perfect. That is the reason you will get a some distortion in the output. So it is a distortion is present in the class B push-pull power amplifier. So class B push-pull power amplifier is also called double-ended class B amplifier. Double-ended class B power amplifier. Okay, double-ended class B power. Next, what is the expression for efficiency of class B push-pull amplifier is? So DC power input. What is the DC power input is? What is the DC power input? It is the average signals. So average or DC value is 2 AM by pi. So what will the PDC is VCC into IDC. So IDC is 2 VCC to 2 IM by pi into VCC. So this is DC output. So what is the AC power output? So VRMS by VRMS VRMS into IRMS. So VM by root 2 into IM by root 2. So what will happen? VM into IM by 2. So overall output class B push pull power amplifier output is PSC by PDC. So what is the PSC by PDC? PSC is VM IM by 2 divided by 2 into VCC into IM. So what will happen? Pi by 4 into VM by VCC. So what is the pi by 4 means? 78.5, 0.7785 actually, into 100 means it will be 78.5. This is the value. What is the value of eta? It is maximum efficiency, eta max by VM is equal to VCC. Whenever VM equal to VCC, you will have a maximum efficiency of 78.5 percentage. Is it clear? Is it clear or not? So what, how we will get a AC power and DC power means DC power input is DC. What is the DC? It's the average value. Right? Average value of current is IDC. IDC means 2 IM by pi because it is a half cycle. What is the half cycle of average output or DC value? 2 IM by pi. So what will happen to the, what is the total power? DC power means VCC into IDC. So VCC IDC will 2 into IM by pi into VCC. And AC power output is VRMS into IRMS. So VRMS means half cycle means VM by root 2. IRMS also IM by root 2. So PAC by PDC means you will get a pi by 4 VM by VCC. And what is the maximum efficiency means VM equal to VCC. So we will get a pi by 4 means 3.14 by 4 means 0.785. So into 100 means 78.5%. So you will get a more efficiency compared to class A power amplifier. For a class A power amplifier, it is maximum of 50 percentage. Whereas class B push pull amplifier, you will get a 78.5 percentage efficiency. So it is more improved compared to your class A power amplifier. You can see in the derivation of efficiency. And what is the advantage and disadvantage of push pull power amplifier means? So what are the main advantage of push pull power amplifier is the efficiency is much higher than the class A power amplifier. Correct or not? It is 78.5 percentage. And there is no input signal, the power dissipation is zero. Correct or not? So if there is no input signal, in the case one we have seen, so there is no signal means there is no output. There is no output means there is no power dissipation. As the DC current components flow in opposite direction through the primary winding, there is no possibility of DC saturation of the core. So DC current components flow in the opposite direction because the positive going cycle and negative going cycle they will cancel each other. So overall saturation of the core, that transformer will not burnt, it will not damage because due to DC the transformer will damage in the, because the transformer will work in only AC. So DC is there means you will not the there, and because of the opposite polarity of these components V1 and V2, it will not having a saturation in the core of the transformer because they will cancel each other, and ripples present in supply voltage also get eliminated. Why? Because it is having a opposite polarity. Due to V1 and V2 are having the opposite polarity. See here, what is the V1 and V2? V1 is the positive going cycle means V2 is negative going cycle. So if you are seeing the overall effect is the, they will cancel each other. Ripples will not present in the circuit. So next what will happen? Due to transformer impedance matching is possible. We already discussed this. So due to transformer is present, maximum efficiency or the maximum transfer of energy will be taken place. So what is the major disadvantage means two center tap transformers because it is costly affair as well as it is a bulky. So and the true center tap transformers will give you a more costly as well as the more bulky. So size is also more. So circuit is bulky as well as costlier. And due to transformer, we have a frequency response is poor. Okay. So in the whenever you have a transformer, it is costlier as well as bulky as well as frequency response is poor. So we also seen in the transformer coupled amplifiers. Okay. So in the in here also we same case we have the frequency response is poor as well as the costly affair as well as it will bulky. So size is high. So this is the class B push pull power amplifier. Is it clear, all of you? Are you able to understood?
Yes, sir.
So what is the class B push pull power amplifier? Tell me. చెప్పండి క్లాస్ బి పుష్ పుల్ పవర్ యాంప్లిఫైయర్ అంటే ఏంటి? Class B push-pull power amplifier. Why it is called push-pull power amplifier? Because there is a Q1 is positive of cycle, Q2 will generate negative of cycle. So one is positive, other is negative. So it will opposite in polarity. That is the reason it is a push-pull power amplifier. One is pushing, other will be pulling. That means one is going positive of cycle, second one is going negative of cycle. So opposite polarity, they will have 180 degrees opposite in nature. So that is the reason they are called a push-pull power amplifier. And they are using two center tap transformers. So what are the two center tap transformer? T1. What is you can call as a T1? What you call as a T1?
Input transformer, sir.
Input transformer, or what is that other name?
Phase splitter, sir.
Phase splitter. What is a T2 you can call?
Output transformer, sir.
Or other name?
Coupled.
Coupling transformer, because it will couple the collector voltage to the load. What is the load here? What is the load?
T2, sir.
Load is loudspeaker here. Correct or not? This is the loudspeaker. You will couple this voltage, the output of the transformer T2 to the load. Load is loudspeaker. Okay. So how many outputs we will get at the output side? One or two? How many outputs you will get? There are two outputs, IC1 and IC2. So total output is IC equal to IC1 plus IC2. So and it will positive of cycle. This is you will get negative of cycle. For example, it will get the positive of cycle. It will get a negative of cycle. So combinedly you will get a positive plus negative of cycle. So complete cycle you will get at the output side. But what is the disadvantage? Major disadvantage? Distortion. We have some distortion because both transistor Q1 and transistor Q2 are not perfect, so output will not also perfect. It will get some distortion in the output side. So it will be this you will see in the crossover distortion. That is called a crossover distortion. We already discussed the types of distortion, amplitude distortion, phase distortion, frequency distortion, as well as a crossover distortion. So Class B push-pull amplifier, you will generate a crossover distortion because from the positive off cycle, it will cross to the negative off cycle. Some distortion is present because there is no perfect on and perfect off of transistor Q1 and transistor Q2. So on to off to on have some switching speeds. So the switching speeds are not perfect. So they are not quickly off, they are not quickly on. So that is the reason some leakage of current will be flown or some current is not present. So what will happen? It will be having some distortion in the signal, output signal. Okay. So you can see in the crossover distortion, we will see in the class B complementary symmetric push-pull power amplifier that area. Okay, so see that efficiency of the class B push-pull amplifier, it is about 78.5 percentage. It is much more greater than the your class A power amplifier. Okay, so up to here you advantage. What is the major advantage? Efficiency is high compared to class A. Second advantage is the there is no ripples present in the supply voltage, and it because of it will be get eliminated. If the ripples are there, it will be get eliminated by the circuit, and the transformer impedance matching is high possible, the high impedance matching. So and the power dissipation is zero. As in the ideal case, it will the power dissipation is zero, and the two center tap transformer are there, so it is bulky, costlier, and phase response is poor. Okay, they are the disadvantage. So this is the your class today. So I will also share the link. Kindly go through it. Okay, right. Then I will end up this class.